All right, we're good? Oh, yes, we are. All right. Good morning, everyone. Morning.
Hello, good morning.
Morning.
Morning. So I'm Dustin Chamberlain. I'm a quality engineer at Red Hat working on OpenStack. And to my right, I have
Tiago. So I'm a developer for OpenStack at NetApp.
Yeah, the same with me. I'm a developer at OpenStack for NetApp.
All right. Let's get started here. So this is what we're going to cover today. We're going to do a brief introduction about what IPv6 is, how it compares and contrasts to IPv4. What is IPv6 in OpenStack? What is its state? How to use it with a practical example in OpenStack, and we're going to use a storage demo with Manila to show IPv6 without natting. So to get started here, what is IPv6? So of course, it's the next generation of the Internet protocol. It's been around for quite a while, since the 90s. It finally became an internet standard last year, which means it's a de facto, this is a part of the internet now. It is a replacement of IPv4. It is not a supplement. There are things that you need to do when you have both IPv4 and IPv6, such as there are some tunneling protocols that you can do, 6 to 4. You can do dual stack as well, where you run both an IPv4 and IPv6 IP stack on your NIC. And the big change with IPv6 is the addressing space. IPv4 has a 32-bit address space expressed in a format that we're all pretty familiar with, where you have 4 octets where the X's are integers between 0 and 255. So you get about 4-something billion spaces. But with IPv4, you have a 128-bit address space, which is massively big. 3.4 times 10 to the 38 is roughly 340 undecillion, which is about 8 orders of magnitude bigger than a billion. And each of those X's there represents a hexadecimal value from 4 zeros to 4 Fs, a 16-bit value. So that leads us to some of the advantages of v6, where we have virtually unlimited IP addresses. There's no need for NAT anymore, because NAT came around because we were exhausting the IPv4 address space, so we had to translate these private addresses into publicly addressable ones. With v6, we have so many of them that there's no need for that. An adage that I heard when I was first learning about IPv6 is that there are enough IP addresses for every grain of sand on every beach, and enough for each human on Earth to have about 10,000 of them, and you still have so many left over. So the standard subnet size is massive. It's 2 to the 64 addresses, which is the square of the entire IPv4 address space. So it's something that you are not going to run out of them, and it allows you to sort of subnet and prefix the things in your data center or in your cloud specific to the things that, application specific or protocol specific even. In the OpenStack context, there's no need to assign floating IP addresses to anything, because one of the benefits of IPv6 is that all addresses are globally routable. So we don't need to assign a private IP to this anymore, or a floating IP. Routers cannot fragment an IPv6 packet. It's actually not possible to do. If a router receives a packet that doesn't fit its MTU, it will actually send an ICMP-v6 packet back saying, that was too big, this is my maximum MTU. There's prefix delegation, which I'm going to talk about in a little bit, and SLAC, or stateless address auto-configuration. So let's talk a little bit about those. First with SLAC. So it allows an IPv6 host to automatically configure itself when connected. And what it does is it sends packets across the network saying, hey, what are the capabilities of this network that I'm connected to? Using neighbor discovery protocol through ICMPv6. And the router will respond to that request saying, here are my capabilities, here is the MTU, here are the things that you need to connect to this network that you're connected to. And in addition to SLAC, there are also DHCP v6 and, of course, static options to set everything up manually. So prefix delegation. With IPv4, most people are familiar with the private IPv4 address spaces that they use within their home or their enterprise, a 10 dot address or a 192.168 address. However, like I said earlier, IPv6 addresses are accessible globally. So we now distribute, when you get an IPv6 address from your ISP, that's globally routable. And so we need to figure out how to assign subnets and prefixes automatically, because doing it at a global scale is untenable to do it manually. And so using DHCPv6, we use prefix delegation to assign an address prefix, and it automates the configuration creation of the publicly routable addresses on the network. And it assigns a subnet to a router, such as a /64, which, like I said before, gives you a massive amount of IP addresses. And the router will then advertise these to the host on the network via Slack or DHCPv6. All right, so I'm going to talk a little bit about Quagga here. And it's an open source routing protocol network suite, and it implements a whole bunch of different routing protocols, OSPF, RIP, BGP, and others. It's GPL, and it allows users to use software-defined networking on their systems. Erlon and Tiago will talk a little bit about how we use it within our own implementations to handle some of the routing concerns with IPv6. We use it to set up BGP in our example here. So with that, I'll pass it off to Erlon.
Yep. I'm going to talk a bit about the IPv6 history on OpenStack. Usually for applications, they are developed in IPv4, and then they do the work for IPv6. But with OpenStack, we had the IPv6 feature worked since the beginning. But initially, as the maturity of OpenStack wasn't good, the support for IPv6 was very low. I mean, very few deployments people had tried to experiment that. And before the Grizzly release, the configuration process was very obscure, meaning that there were a few people working with OpenStack, the developers, a few deployments that used to try and to do IPv6 in some specific scenarios, but most of people didn't know how to do that. And we didn't have a reliable way to, an easy way to have a guide or to have a way to go and implement a deployment with IPv6. In Icehouse, Juno, and Forward, the adoption of IPv6 starts growing, and mainly in the Grizzly release, it was added some support for IPv6 in the RPC services. That happened across several projects from Nova, from Cinder, Neutron. They added support for intercommunication process in IPv6. And then the maturity of OpenStack, of IPv6 on OpenStack started to growing. And according to the releases when passing, there was several incremental updates and bug fixes, and the thing that was already supported now started to got adopted among people and users. There started to have big use cases. Neutron, which had the main problems and the main work to be done on this area, had some milestones, starting with the Grizzly support for the IPv6, and then adding support for Slack in Juno, the Kilo support for IPv6 prefixes on Neutron routers, and so on. But most of the improvements were bug fixes and things related to specific scenarios and new features that were being added to OpenStack. So the same goes for Cinder. And what's up with this presentation is we are here to tell that in Manila, we have added and we have been working on IPv6 support since the Pike release. And we did the initial implementation of IPv6, adding support for IPv6 access rules, IPv6 export locations, and also we needed to add support on the Neutron plugins. And, but in this first release of OpenStack, we only had some testing deployments. It wasn't thoroughly tested through vendors or even through third-party support partners. And in the Queen's release, we started to add vendor support. So vendors started to work on that. NetApp started to support IPv6. We added some plugins on DevStack, so now we can test all the patches that runs against Manila on IPv6. And now we can say that we fully support IPv6 on Manila. And that's the call of the talk, because Manila was one of the last projects of OpenStack support IPv6.
Okay, so now I'm going to show some examples on how to get your OpenStack running with IPv6, and some examples, a dev environment example, and then a more practical one. So starting with the dev example, so this is a simple example on how to get something ready on your lab to get testing IPv6 and seeing how it works and if it suits you. So in this demo, we have used our dev lab hypervisors and storage. So we have our devices connected to switches that support IPv6. So we have two networks. Of course, we have the management and data network. And both bare metal hypervisors and our ONTAP storage device is connected to these networks. So on this example, we will have OpenStack running on VMs on those hypervisors. So simple KVM VMs on hypervisors, and DevStack for an OpenStack distribution, which is a simple one. And we can use the Manila plugin, which was implemented in Queen, so we can get most of the IPv6 configured by the Manila plugin. In this example, each tenant has a router, which works as a gateway to the public network. And then for this, to route those packages for the correct router, we use BGP, so that's why we need Quagga. So Quagga will run the BGP protocol to route those packages back to the correct routers there. And in this case, no floating APs are needed. So we can access the VMs from OpenStack. So the server instances we can access from within our hypervisor. So we have 3 layers there. So we have the hypervisor and OpenStack running on a VM on the hypervisor and the instance on OpenStack. So we can access the OpenStack instances from the hypervisor. So that's pretty cool. And we can actually get everything communicating from outside of the OpenStack network via its private IP. So just to explain the network, we have 3 tiers. So on IPv6, we have the hierarchy, right? And this, we are using a 3-tier hierarchy. So we have the admin tier, which is the network that the hypervisors are connected, that we called FD12. So going down 1 level, we have the hypervisor tier, which is FD12.1, and then the DevStack tier, which is FD12.1.1. And then we have 2 subnets, the public, which is the first, the second actually, and the private, which is the first, so 0 and 1. And in this same scenario with IPv4, in this case, we are not using floating APs. With IPv4, the most common scenario would be to use floating APs so that we can get everything communicating from outside of the network. This is the local conf that we are using, so that this is mostly for the recorded session, so that everyone can look at this and get everything working the same way as we do. This is a picture of our physical architecture. So the blue bars on top and bottom, these are our networks. So on top is the management network. On the bottom is the data network. We can see the interfaces. So ETH0 and P1P1. ETH0 is the admin interface on our hypervisor. P1P1 is the data interface. And on ONTAP, We have the manage interface. And on the bottom, we have our data leaves, which are our vServer IPs. And also, also on our hypervisor, we have this, I'm using the mouse pointer here. So we have this bridge, which is a bridge that all VMs connected to get access to the network, right? And this is the picture of the routes that we need. In this example, we need to configure one route manually, and the other ones will be configured by BGP. So we have the hypervisor, the bridge that connects all the VMs, and then the OpenStack here. So since we have OpenStack running on a VM within the hypervisor, we need to configure this first route here so that the hypervisor can get those packages from the storage back to the OpenStack machine, virtual machine. If we were using a more real production environment, we would have OpenStack connected directly to the data network. So this is a simple, just because it's a simple dev lab example, we need this route manually. Those routes on the OpenStack side, these are all configured by BGP. So here we have only one router, but for each different tenant, there will be a different route. So we will have BGP working to create routes so that it knows to which router it should route those packages. And now we have the dev environment demo. So this demo will get a setup from scratch. So I will get a fresh hypervisor with no IPv6, only IPv4 running. So I'm configuring, since the IPs on the hypervisor, to get DevStack running and everything from scratch. So the first step, of course, is to configure the IP. So I'm logging into the hypervisor and configuring the IPs. So admin interface, and then management, and then the bridge. OK, management data, and now the bridge. Then I will log into the VMs. Yeah, test everything on each step. So I can ping my storage. I ping ONTAP admin, pinging ONTAP data interface. Now I'm logging into my VM. This is a fresh VM, so it only has IPv4 configured, so OpenStack 1. So this is the default IP, so I'm adding the IPv6 here. And now I'm configuring the default route so that it knows where to route everything. Forgot sudo. So now test everything again. So now I can ping my interface, and I will ping my storage. So to ping the storage, I need the routes configured on my storage. So I'm configuring the routes back to the OpenStack on my storage. So this is the ONTAP interface, so creating those routes on ONTAP. So the management route, and then the data leaf route. Now I am able to ping everything from my OpenStack VM. So this is my OpenStack VM. It doesn't have OpenStack yet, so OK, so now I can ping admin and data interface. So all the networking is done. So now I can download DevStack, get everything configured, and start stacking. So cloning DevStack, configuring it. I'm using that the local conf that I showed you. And now stacking. So it will cut now because, yeah, everyone knows how to stack. And at this point, I have OpenStack running. This I just allowed access to the ping and SSH port so that I can test everything and get SSH working. So now I'm configuring BGP. This step is also on the Manila plugin. So all those commands are on the Manila plugin for DevStack. And now I'm configuring some routes. The hypervisor needs that route that I showed you on the slide, so I need to configure this route manually. And now I should be able to create a VM and get this VM pinging everything, and everything pinging the VM and SSHing into the VM. So I'm creating a simple VM here. I'm attaching it to the private network. Cutting again because the VM is booting. So as you can see, the VM has the private IPv4 and the private IPv6. So I'm going to use this IPv6 to show that I can SSH and ping from the hypervisor. So 2 layers above OpenStack. So this I'm pinging from OpenStack first. So on a IPv4 scenario, this wouldn't be possible. And now from a hypervisor, I can also ping this. And I can also SSH from the hypervisor. And I can also ping my storage. So without any other configuration, I can ping my storage, and I can get all those packets back from the storage to my instance on OpenStack. And now, just to show that everything's working fine, we are going to configure Manila with our ONTAP driver, and then using IPv6 to communicate with the storage and IPv6 to mount the shares. And then we will get a share mounted on our VM. So configuring Manila. So as you can see, we are using IPv6 to communicate with the storage. Just setting the enabled backend. Restarting service, creating share type. OK, so creating share type, and then creating the share, and then allowing access, and then mounting this share on our VM. So the share is available, allowing access to the VM. First, I need to get the IP. And then getting back to the VM. Yeah, this is another step. Since we are using the VM, we need to open the NFS ports, of course, so that we can get everything mounted. So on Manila Show, you can see that the export locations, we have the first one, which is the IPv6 export location right here. And then we also have the IPv4 export location here. Oops, sorry. So I'm copying the IPv6 one. I'm back at the VM. And now mounting the share via IPv6. So as you can see, it's mounted via its IPv6. So yeah, as you can see, it's pretty simple to get DevStack running. We can use, especially if you're using Manila. So the Manila plugin basically does everything that you need to get everything set up. And only a few steps to configure Quagga and open an NFS port, but this would be necessary even in IPv4. I mean, the allowing ports and getting the permissions right. So as you can see, it's pretty simple to use DevStack for that. And to translate this dev testing architecture into a more production real architecture is pretty simple as well. So it would need some changes, of course. But most changes are network related because we wouldn't use a hypervisor for the OpenStack VM. So OpenStack would run on bare metal. In our environment, the data packets are being routed through the hypervisor. So the hypervisor is connected to both networks, and they are being routed by the hypervisor to OpenStack. In a real environment, on a more production one, OpenStack would be connected to these two networks, so we wouldn't need to route those packages within this hypervisor. So and of course, OpenStack would be deployed on this bare metal, which is connected to both networks. But the configurations on OpenStack wouldn't change much. So this is a new architecture, a new physical architecture for a more production environment. So we still have management and data networks, of course. We don't need the bridge anymore because this would be, our node would be connected directly to the data and admin networks. And we have here the routes. The routes are actually simpler. We don't need to configure any manual routes anymore. So the only routes that we need would be configured by BGP. So are the top ones here. And BGP would be responsible for configuring those routes automatically. So we wouldn't need anything. And the rest is pretty much unchanged. So the translation from this more dev testing to a more production one, it's not that difficult, and it doesn't change much.
Yeah, so I'm just going to do a quick note here on V6 and OOO, and the long and short of it is basically it's very easy. When I deploy my environments for testing, to deploy IPv6, I basically say deploy with IPv6. There are already OOO heat templates that exist that will use a different allocation pool for V6 other than V4, and it does all of this automatically. So for me, it's not a big ask to deploy with V6 with OOO in my environments. It's actually very, very easy.
Do we have another one?
No?
Yeah. So yeah, that's about it. We're open for questions now. Do you guys have any questions?
So I have one question. I was a little bit late. Can you use the microphone so the stations record your audio? Yes, sir. Of course. Otherwise, the people online.
Okay. Yeah, I here just have a question. It's possible to have at the same time IPv6 and IPv4 on one?
Yes.
Yes.
Yeah, actually in this presentation, we are using IPv4 and IPv6. As you can see on the demo, let me find. Yeah, there we go. So as you can see there, we have our instance is connected to the private network. And the private network is both IPv4 and V6. So it has an IPv4 address and IPv6 address at the same time.
Yeah, it's one NIC with both a V4 and
Yeah.
V6 address.
Yes.
So question, why are you configuring everything with 128 addresses? RFC3909, I think it is like, this is my big bugbear with OOO, is this should all be run by DNS. Like you shouldn't be putting in V6 addresses into your Neutron for anything other than ACLs. So when you do your config in OOO, you should just be putting NFQDNs and letting DNS steer this. This is a big problem for some of our deploys at the moment.
Good to know.
But yeah, is there any reason is the question? Like why are you not using FQDNs in the config files?
I haven't the foggiest.
Okay, so I'll be quick. I was wondering whether this is something that you plan to integrate into the Manila desktop plugin, because rather than going and do all those hacking beforehand and so forth, this really looks like a good use case and a good improvement that could be done to the Manila desktop plugin. And I don't know if you have any plans to draft this as a blueprint and work on that.
To get it working on what? Sorry, I couldn't.
Yeah, so all these configuration about the IPv6 stuff that you did and so forth, like the Quagga, all the routes and so forth, maybe that could be just added as an option into the Manila desktop plugin.
It is on the DevStack plugin. I mean, most of the commands that I showed you, they are simple copy and paste from the DevStack plugin. So if you configure, you need to use the correct parameters so that it gets triggered to run. So if you use the localconf that I just showed you, it should trigger those steps. Okay. Because it has some verification. If you don't use those correct parameters, it won't trigger the configuration for IPv6.
That's manually for the showcase, but already implemented. Okay, so thank you.
Okay.
So your example was dual stack. If I didn't want dual stack, if I wanted IPv6 native only and no IPv4, does everything still work okay?
Yes. We actually started testing IPv6 only with IPv6, but then we were told that it's more common currently to use IPv4 with v6, so we changed our lab to support it. But yes, it's possible. There's on DevStack, we are using the configuration IP version 4 plus 6. If you use IP version 6, it will be only IPv6.
Same question for all the other OpenStack projects. Have your testing done IPv6 across all the projects? I mean, Trove, you name it, all those other things, do they all work, or do we just have basic networking?
Well, we know that for Manila, we have the continuous integration systems for IPv6. And for the other projects, I can't say, but I know that there are people running IPv6 scenarios from a long time. So I can say that they definitely work with IPv6 across OpenStack projects.
And from my perspective, from my deployments with OOO in my testing environments, when I say deploy with IPv6, it sets up the keystone endpoints so that all of the services are talking IPv6 to each other. And I haven't noticed any issues with my testing. Granted, I'm focusing on Manila, but Manila talks to a bunch of things.
So in this demo, you used addresses in the FD/8 range for everything, which is, of course, a unique local address and is not globally routable. Mm-hmm. You also said that for the production environment as well, which, of course, implies that it's a local-only cloud. Would you ever want to make this completely globally routable and use the delegated prefix, and what changes would you need to make that happen?
Yeah, the address would, of course, it would change. So, yeah, it would need some subnets to get it routing, and it would go some levels down. So, yeah, but it should be fine too.
So the way you had it set up, you were using 12:1:1, which was a completely hierarchical setup. But if you were going to use a 48-bit prefix, you'd only have the last 16 bits to work with, right? Would you then break everything up in that?
Yeah, probably. Yeah. No more questions? No more?
Yeah, so I had a question. So my understanding is if you just had an IPv4 infrastructure, you can still provide IPv6 to instances. So my question is there an advantage to have your OpenStack infrastructure IPv6?
You mean the backend? Your data path or data plane in IPv6? Well, if you look for the initial motivation for IPv6 was the lack of enough address spaces. So depending on your deployment, that might be not necessary to have an IPv6 configured, because even if you use IPv4 for the data plan, for most of scenarios, that is enough, right? So it will only depends on the deployments. So.
Thank you.
Hi, so I have now only IPv4. Is there something I should think about if I want to add IPv6 to my current OpenStack?
I know from my perspective, when I started doing IPv6 testing was there are a lot of things that you get with NAT that you don't get with IPv6, not out of the box anyway, that you have to configure with Quagga and BGP and all that. There are a lot of things with just my dev environments and testing environments that were a little bit more manual that I had to set up. But now that I have them set up, it's all nice and easy. But with these massively virtualized environments, they're already complicated enough as it is, and it abstracts a lot of these things out. But knowing that you need to use stuff like Quagga and BGP, and it'll do it for you, that's a big help. But I don't know, do you guys have anything else to add on to that?
Yeah, you will have some problems with routing.
Yeah, that's what
challenges,
I would say, the routing part, because if you have only IPv4 scenarios, you can do static routing. But for IPv6, you always will need to use BGP or Quagga to do the routing. So it adds a bit of complexity, and also because it's not something that we use since we start to using computers. So there's some complexity on that.
Right, but as we showed in the demo, you can configure BGP via Neutron.
Exactly.
So there are commands there for it.
Yeah, question. I'm sorry, were you going to continue?
No, go on.
In data center with IPv4, traditionally, it's been a best practice to use static addressing. And I wonder, in your experiences with IPv6 and OpenStack, have you found any reasons not to use Slack for IPv6?
Not to use Slack?
Yeah, is Slack, and have you heard from others, like do people just generally, hey, Slack's great for data center?
Yeah, didn't hear anything about that, but for this scenario, it's more a question of the didactical scenario. It is supported to use Slack, but just for this scenario, you didn't use it. You want to add something?
No. From what I've understood with Slack, it tends to be the easiest way of configuring your addresses. At least in the neutron context, you can also set up DHCPv6 stateless and DHCPv6 stateful, each one of those being more complicated than the previous. So I found from my purposes that Slack has been fine. Anything else?
No more questions? You had anything else? No? Okay.
Thank you, everyone.
I think that's it.
Thank you, everyone.
Thank you very much, everyone.